So you guys help me with this. And be honest, I'm not going to attack you or anything. How many of you thought it was kind of a little rough going back to all the integration techniques? Ooh, we got many of this, okay. I'm sure you would raise your hand if it's been a while. But again, that was the whole point behind that. Sneaking in an extra quiz. But you'll brush up by next Friday, right? Anybody in here ever heard of Omar Bradley? He
was a general during World War II. He was originally subordinate to Patton, and later he commanded the D-Day invasion.
Yeah, in the European theater of the war. And he would often have to spend his time in those lumbering DC-3s. He got really bored. So whenever he landed somewhere, he had his staff scour the area for sheets of integrals. So when he was up in the plane, he could just evaluate integrals, solve integrals. So,
Yeah, to ask you to.
Well, everybody, let's come back to vectors. If I just restrict my attention to two-dimensional space, and I've got some kind of curve described by a vector value function. And this curve is described by this vector value function. Then I maintain at a particular value of t, say for example, how about t1? Bless you. Maybe the case the tip of that vector describes a point on that particular curve. However, I think when it comes to the derivative of that vector value function, I think there's meaningful interpretation. I think the derivative of that vector value function should give you the change in r bar t at that particular value t, which I think in the end really should give you another vector that's tangent to your curve, at least at that particular value t. And of course, if r bar t is a position function, then jeepers, you guys, you've been through this so many times in Math 30 and 31. If r bar t is a position function for a curve in two-dimensional space, even 3 as well, then I think r bar prime at t might represent, or could be interpreted as, velocity. And so I think r bar double prime at t is going to represent acceleration. Now, it might be a little difficult for me on the board to show you, geometrically speaking, how the acceleration vector looks in general. But certainly if the original position function is quadratic, then I think the first derivative function, r bar prime t, is going to be linear, which means r double prime at t, which could be interpreted as acceleration if the original vector value function is a position function, could be, or is necessarily going to be a constant, and all the arrows are going to look the same for acceleration. That certainly will be the case. That's kind of hokey for me to be saying that because it's very limited. But again, I'm just stalling because it's really difficult for me on the board to show you exactly what a bar t looks like if r bar is a position function. But that also suggests that if r bar t is a position function, then r bar prime, like I just said, could be interpreted as velocity of that particle. It's a vector value function. And the second derivative for r bar t is going to be necessarily interpreted as acceleration vector as a vector value function, but again, if the original r bar t is a position function. Now, I maintain something kind of interesting happens in higher dimensional space. If I had a vector value function that has a quality that its magnitude is equal to constant, then something really interesting happens. And before I give you the punchline, you guys, can I just walk my way through this instead of just telling what it is? Now, you got to be careful what I have written on the inkboard with my beginning sentence, my first phrase. I'm not saying that the vector value function is a constant function. That's not what I'm suggesting. I'm just suggesting that its magnitude is a constant. By the way, if the magnitude is a constant, what do you think this says about the curve I'm currently drawing out in free space? If the magnitude is a constant. Say it again. Free space? Sphere. Okay, so I think in three-dimensional space, I'm just simply living on a sphere. What you're saying is just fine. It's just in two space. If the magnitude is a constant, I'm living on a circle. And I get the analogous result. However, if that really is the case, then check this out. If the magnitude is a constant, then what do you guys think you can say about the magnitude twice? constant, it's just c squared. However, if I came in and differentiated, I think that would be significantly different. And I am going to differentiate. It's just before I do, because of what I've discussed so far, I will interpret the magnitude squared as the dot product of a vector value function with itself. So if I differentiate, using the product rule of dot products, don't do this. Oh, but shoot, I'm the one who came into class and proved to you that there is a law of commutativity for dot product multiplication with vectors. So I guess what I really have is just simply two of these things on the left-hand side. Do you mind if I don't write it? Can I just divide both sides by 2?
Wait, is O equals 0?
And it is a 0, it's not a vector, it's a scalar. Jeepers, nobody jumped. Eric.
Is this supposed to be R, a vector R prime of t? Because sometimes it's hard to tell, so.
Yeah, that was
Okay.
an R bar prime of
Okay.
You guys, come on, somebody say something. What have I just shown? Yes.
Well, what you're basically saying is this, because it's just the magnitude versus a whole vector when you differentiate. Or sorry, wait, are we talking about differentiation or integration?
You know, from here to here, I did differentiate both
Okay.
sides.
Where when we're squaring, we lose the direction because we get a scalar back, whereas before,
You know, that's a good point. Yes, you're right. I agree with that.
Well, that makes sense when I get 0, because when you differentiate your position, you're not getting any change, so when you get 0, your magnitude is still the same for the position.
But it doesn't say that the derivative function is a constant function. I think this is something more interesting. You guys, we have a test on dot products next week. If the dot product of two vectors is equal to 0, what does that say?
They're orthogonal.
Thank you. And so I think if you've got a sphere here, and there's some curve on the outside, it could be crazy looking, but the magnitude is constant for the vector valued function, then at every single point, if you emanate a vector from the origin, its derivative function is orthogonal to it. Same thing works back down in two-dimensional space. If I got a vector valued function that's describing a circle, then check this out. X-axis, Y-axis, I think bar t looks like this in green. For a particular value of t, there's my r bar. It's just that r bar prime is going to be orthogonal. I've just maintained, I've shown it that it's true in any dimensional space, particularly third dimension.
That makes sense, because it's like taking the derivative of a curve.
True, it's just a very special curve where a vector value function has a constant magnitude.
yeah.
Yes, sir.
So, does this have to do with circular motion?
Can you see the little arms? So sorry.
Does this have to do with circular motion?
Dramatically.
Okay, that's what I figured by the tangential vectors.
But I gotta confess, I was speaking in a higher dimension. I really was trying to suggest that what happens if this is going on a sphere. But you're right, it certainly is true with circular motion, just in a two-dimensional space. I agree.
So I guess then it would be spherical motion?
I guess I've just never heard a word that way. I've never heard it said that way in English, but I suppose I can learn it.
How would that look though? I mean, would it have to change course as
Maybe it would look.
That's what I'm saying. You guys, check this out. I know I can't draw this very well, but if I got a sphere sitting right in front of me like a globe, I'm saying stay on the globe and just go in these crazy trajectories all over the place, but staying on the globe. So you're constantly the same distance away from the origin at the tip of your vector. No matter how crazy that curve looks, every single tangent vector is going to be orthogonal to the position vector going up to that point from the origin. That's what I'm suggesting.
So it would look similar to like electrons orbiting the atom, where you've got no clue where actually they are, but they are at a certain distance.
If you believe the Born model in chemistry, yeah. But, you know, we all know that that leads to natural logical contradictions. But you're right, if that were the case.
Just a quick question.
Yes.
What's a tangential vector supposed to represent in this case in a spherical space? I mean, usually it's the tangential velocity.
Well, you know, in this case, if you want to talk about motion, and that green r bar is really just describing the position of the vector valued function, I think your r bar prime really is representing how fast it's changing. It is a velocity function, because I'm assuming the original green one is a position function. So I think the same thing holds true, like back in Math 30, it's just Math 30 was different, you're dealing with continuous scalar valued functions, not vector valued functions.
It's because we're letting the direction change, right?
It's because, I'm sorry,
I mean, the reason it works is because we're letting the direction change.
yeah, but you know what, before I did the blue one, I didn't know direction changed. I was just talking about the position changing, and now, you're right, the direction is changing, I agree, but
Well, I
in
mean,
an orthogonal
the
fashion.
direction of the green vector is what we're allowing that to change, right?
Yes, I am.
Okay.
I agree. And I can describe that change through the differentiation process. Yes, I agree. By the way, since somebody kind of talked me into coming back over here and looking at the circular motion, do you guys think the magnitude of the blue vectors are going to change?
Probably not, I mean,
Yeah, probably not, because all these green vectors are basically saying magnitude, or just moving in a circular fashion in a constant rate, constant vector rate. And so I think what's going to happen with my red pen, let's go with red pen, Alex, do you mind? I think when it comes to acceleration vector, what do you guys think it should look like? With everything I just said, at that particular value t. It's orthogonal to what you see in blue. I agree. I think that's what the acceleration vector should look like. I know I told you over there in the first picture, I don't want to draw the acceleration vector, but this is just each case scenario. I can do it.
so the acceleration vector in this particular case is directed back towards the origin, and that's what's keeping the position vector
Yes.
at the same magnitude.
Yeah, and by the way, those acceleration vectors are really interesting. You're going to find this out when we dive deeply into it this semester. Like, for example, you're driving a car. You turn a corner at a certain speed. If you turn the same darn corner in the same fashion at a higher speed, what's the difference? What do you
have to
feel?
have higher acceleration.
What acceleration?
You have to have greater acceleration, what's the word?
Radially.
Radially inward.
Okay, good. I wouldn't use the word normal, but I understand what you mean. I think the normal component acceleration may not have a linear relationship with the magnitude of the velocity. Maybe it's something more than that, and I'll prove to you it is this semester.
I'm just thinking like, okay, like if we plug in a function, a vector value function for r, and then integrate or differentiate that, then it'll just go to 0, wouldn't it? You have like
You know, it's not your fault. I just lost my train of thought. I apologize. Can you start that again? It's my
like
fault.
if you plug in like t squared for r of t, and
Yes.
nothing for the y direction, and then integrate or differentiate that, that would be 2t, and then differentiate that, that'd just be 2. So,
So the acceleration is constant.
okay.
And you know, I probably would have given up. I would have just said, forget vectors. Let's just deal with Math 30. Just one single function since the y component was equal to 0.
Yeah.
But you're right. You can do that. How does something like this?
Archimedes?
Yes.
Archimedes got fat. What are you feeding him?
So, back came close to Archimedes, my cat. And Archimedes decided to get his paw out and swap the thing. And he swapped the thing in such a way that the initial velocity at which that particular bat was flying was going to be, I don't know, you guys, I'm just making these numbers up out of thin air. How about in the direction of 5, 5, measured in feet per second? And suppose that he did that in such a way that his paw was going to make sense, is maybe a half foot high off the ground. So question, he hits the bat, it loses its ability to fly. How far does it travel before it hits the ground? Those are questions I want to be able to come up with. Can I take a break from my particular example? Let me talk a little bit of theory. So a little bit of theory. Would you guys agree that force as a vector is equal to mass times acceleration?
Yes.
And I think if I draw a nifty little picture, x-axis, y-axis, you guys, just for a brief time of the clock, let me restrict my attention to just two-dimensional space, and I promise I'll jump into three space with this. Let's start off with the basics. I think when it comes to Archimedes having, let's forget about Archimedes. Let's talk about a particle whose initial position is even over here. And so whose initial position is going to be located at x sub naught comma y sub naught. And let's just suppose that its initial velocity end up being, you guys, I'm making these up again. How about u sub naught v sub naught? Before I actually hit this object in the direction of its initial velocity vector, I think the only force acting on this particular object that I'm throwing around is going to be gravity. It's just that I think when it comes to mass times acceleration, this is going to be nothing more than a vector that you see in blue that is moving in this vertical direction. And I think as a vector, it's simply going to be one that has the first component of 0, like a piece of cake there. Whose second component is just negative m times g, which is a gravitational constant. I guess when it comes to Archimedes, I'm really thinking of g as being negative 32 feet per second squared, but I confess, if I had put meters per second, you know that the g is going to be measured as negative 9.8 meters per second squared. If you didn't know that, there are the constants. However, I maintain that this implies my acceleration vector is going to be nothing more than 0, negative g. I don't have to worry about the mass when I just want to discuss the acceleration. Now, the reason why I mention accelerations, I'm asking you, how far is this back going to fly or hit through the air before it actually hits the ground? I want to talk about the horizontal component of that trajectory. And I think I could do it just by starting off with acceleration, anti-differentiating, coming up with velocity, anti-differentiating, coming up with the position function of that bat flying through the air as time goes by. So I'm really trying to come up with r bar t. I think initially, you guys, I'm only changing colors, no matter what. I think initially, that's better. My a bar t is merely equal to this. I confess it's just a constant function for the y component. But if I were to anti-differentiate to come up with a velocity vector, I think I'm simply going to end up with 0, negative gt. You okay with that?
Plus c, plus.
Oh, you're right, I forgot, so I don't know. How about
Plus
C? How about C sub
not
naught?
V naught.
What was that? Sorry.
V naught is going to be your C.
I agree completely. Before I do it, I think there's a huge mistake on the board. Where is it? Yeah, I'm adding a scalar to a vector. I didn't mean that. I really want that to be a vector. Or shall I say V bar T? So, Eric, no R's. No story symbol. So I think I got 0, negative gt plus a constant vector. I think I just call it down. How about C1, C2?
Gorgeous.
Or shall I say V bar T is equal to 0 plus C1, negative gt plus C2. It's just that, you guys, my initial vector for velocity.
It's 5, 5, so.
You guys, what letters did I use?
V naught.
Thank you. Use of not and V naught. Oh. Sorry. To make you yawn. And if I put this in for the vector value function on the right-hand side, I just think it means u sub naught, v sub naught as a vector is nothing more than what you see on the right-hand side, replacing t with 0. And I think I get this. You guys, I'm writing too much ding for it. What I'm really suggesting, as someone mentioned, is that C1 bar is nothing more than u sub naught, v sub naught. And so I think I'll rewriting this statement right up here, I maintain that v bar t is nothing more than, is that my u sub naught, my negative gt plus v sub naught? Oh shoot, you guys, I still didn't answer my question. I want to come up with a position vector, so let me anti-differentiate one more time to come up with r bar of t. In anti-differentiating, can I skip some steps? Don't I come up with this? Is that a u or v? Is that a u sub naught? So u sub naught t plus something. Comma is is that my negative 1/2 GT squared? Is that plus my V sub naught times T? Plus something else? But you guys, when I set my initial position, my initial height, positions here, I just simply meant that's R sub naught bar. So if I plug in for R sub naught bar over here when T is equal to 0, X naught, Y naught, but correspondingly 0 for T here and here, doesn't it just simply mean a question mark and pound symbol? Or X sub naught and Y sub naught respectively? Please tell me if I'm skipping too much.
Makes sense.
That means, arithmetically speaking, I can rewrite R bar of T as being nothing more than a vector whose first component is U sub naught T plus my X sub naught, comma negative 1/2 GT squared plus V sub naught T plus my Y sub naught. Yes,
Why exactly do we don't have an acceleration portion of the X bar? I mean, I
Yes.
can understand because he's only being accelerated by gravity, but let's say we strap an Acme rocket to the back of Archimedes' hand,
yes.
and then he beats the crap out of the back.
But I think even if there's a rocket behind his paw, by the way, he has a paw, not a hand, but
Okay.
if there's a rocket behind his paw, I think that's going to affect the initial velocity. I still don't think it affects what's going on with the bat just prior to the paw hitting.
Okay, then let's strap an Acme rocket to the bat.
Then you've got the
Problem solved.
That's different.
You have a
And you know
space
what?
bat.
I'll take care of that when I go into three-dimensional space. You're right, how about saying it differently? Before the bat hit, there's a constant wind speed, horizontally, of certain speed. I think that'll have an effect on the initial acceleration in the horizontal component.
Okay.
I agree with that, that's true. But they're sitting in my house, the windows are closed.
So then you would have two accelerations, like
True.
one in the X, but two in the Y. How would you reconcile gravity and the opposite, or would they give you different?
You know, I didn't mean that. I meant only horizontal wind, but you're right. I could have had a non-horizontal wind. It just means I've got to add something to the Y component of my
Would
acceleration.
you add the vectors,
Yes.
get gravity and the upwards?
Yes, and I admit, if I did that the way I'm writing things, I consider the acceleration for gravity to be negative. And if the wind were blowing in an upward direction, I'm adding a positive thing to a negative thing for the second component of the acceleration. I can easily do that.
But you would get it by adding.
You would get it by adding, yes, I agree completely.
Gravity's negative only because you keep your coordinates in that way.
Now, be careful. I can't say that gravity is negative. I'm just saying the way I'm drawing my picture, I consider it to be negative. But you could certainly say gravity is positive, just switch everything around. And half the math textbooks I don't do exactly the same thing. So everybody, I haven't answered my question. How far does a bat fly through the air before it hits the ground? Can we just assume Archimedes killed it, so it's not flying anymore? When he hit it with the paw, it's no longer alive. How far is it going to fly horizontally?
Are we talking just the horizontal component?
Yes, that's what I'm really asking.
Okay, then all we gotta do is substitute, the, R naught and, gravity component.
Solve for T.
Oh, okay, all right, you guys help me. I forgot the numbers I made up. What was use of naught? It was, I can't read it. I can't read it. I can't read it.
5
feet per second.
I think it's irrelevant right now. I think what I want to do is take the vertical component and do what with it? Set it equal to 0 and solve for T. Once I solve for T, I can plug it in here, then I'll leave use of naught and find out what the range is. Did you guys see that? Let's do it. Before I do, does anybody have any questions on the middle board before I erase it? Okay, so I can get rid of it?
No, why are you putting the Y component
When he hits the ground.
to 0?
Oh, Linda, I'm not doing a good job. Check out what the bat's doing. It's doing this. Plunk, hits the ground.
Okay, so we're trying to find.
I'm trying to find the range.
Gotcha.
And I know you're used to thinking of range of functions back in math P as Y guys, but here the range is just to be how far is traveled horizontal. And so would you guys not agree? Find out how long this takes. I just take the vertical component of the position function, find out when it's equal to
0.
0. I'm going to do just that. I'll take that vertical component, which is negative 1/2 G. What negative 1/2 G is?
9.8.
Negative 4.8.
4.9. That too.
You have
I apologize. I could do my arithmetic. I would agree with 4.9.
Are we doing
are we doing?
So it'd be like.
Wow, I really messed up, sorry, I'm thinking metric units. So instead of negative 4.9, we'll do negative 16.
People, what?
T squared.
I was just saying, what? Who uses feet per second?
When I made up the question out of thin air, it just naturally turned out that way. I promise I'll be better with my next example. I'll use metric cubes for my next example. Actually, I don't remember the rest of you guys. Plus V sub naught, what was V sub naught?
5, I want to say.
What was H sub, or the initial height?
Ground. Oh, it's okay. It's half a foot up.
I'll set that equal to 0 and solve for T. And I maintain T is going to be nothing more than negative 5 plus or minus the square root of B squared minus 4AC all over 2A. Or shall I say T is equal to 5/32 plus or minus the square root of jeepers, is that a 57?
Yep.
All over 32. You guys, do you mind if I bore you for a moment? I mean, just to see how realistic this example is, do you think I can bore you to death by just cranking out my numbers? And look, I don't have any notes. I really didn't make these numbers up out of thin air. So I have no idea what the answer is. So allow me. Oh, jeepers, I can't read that. Is it 5/32?
Yeah, but isn't that supposed to be a negative 5? Oh, no, never mind. I'll shut up.
Yeah, just check my assignment. No, don't be quiet. You know I make those silly mistakes. How about the square root of 57 divided by 32? I came up with 0.39. Is that measured in feet or?
Seconds.
Yeah, it's measured in seconds, and I haven't answered the question. I asked, how far is it back on flying before it hits the ground? How far horizontally does it travel before it hits the ground?
So, 1 units plus or minus.
You know, you're right. In my head, I was thinking this would be a little bit bigger than root 49, which is 7. And negative 7/32 minus or plus a 5/32 is going to be negative. So in my head, I saw that that was going to be a negative value. I just rejected it.
So if we're working that in variable form, how do we decide to give an answer positive or negative?
I think trivially, I can only take the positive component of this answer because time starts at t equals 0. I'm not going to go back in time.
But I think he's asking, let's say theoretically we're not working with time. What if we're working with something that can be negative? Would we just give you both answers?
If it had a meaningful interpretation in the problem situation, sure. I was just simply dealing with moment or movement.
Yeah, you're talking about in like real life. You can't have a time equaling negative.
Well, I think in real life you could have time be negative in certain contexts, just not in this context. Archimedes is not going to bring back his paw and go back in time. But I mean, in some cases that would be considered bad. My poor Archimedes, everybody makes fun of him.
Well, poor Archimedes, the bat's the one that died.
So are you guys ready? Let's finally answer the question. I think the actual range is going to be nothing more than my x component. I think it's going to be my use of naught.
5.
Thank
Oh,
you.
yeah, 5.
Times my t value. Plus my x of naught. You know what, you guys, what am I considering x of naught to be in this case?
0.
Yeah, I'm just considering it to be initially 0. And I think that merely ends up giving me. You make me do all the work. Is that right?
Maybe.
Wow.
So a little under 2 feet. That's how far the boundary contours are. What did you guys think that you could say about the maximum height at which this bat reached?
It'll be when v sub y equals 0.
Thank you very much. I agree with that. I think this is when the velocity is equal to 0. That's when it's going to happen. Do you mind if I don't write that down in words? So question, what's the maximum height the bat attains? I think all I'm going to do is take my velocity function, which by the way is negative gt plus v sub naught, or shall I say, negative 9 point, I'm using metric again, sorry. I meant negative 32, times t plus my v sub naught, which was 5, and set it equal to 0.
Why
And
would-
yeah.
I'm sorry, why would the velocity be 0 at the top of the curve? Because it would still have horizontal motion.
Well, the thing is, it doesn't have any more
True.
vertical motion.
I agree, I still have a horizontal motion, I'm just saying, to find out when the bat reaches maximum, I'll just look at the vertical component to
Oh,
see
just
when the
okay, I
velocity.
got you, okay.
The velocity vertical component is gonna be 0.
Right, okay.
And I think that just simply tells me that t is equal to 5/37. Oh, shoot, I blew it. That doesn't answer the question. I wanna know what the maximum height was.
Now, r sub y.
You plug it back in.
You
Oh,
just
whatever.
plug it back into your vertical dimension for r bar t. Looking at the vertical component of r bar t, I think I've got my negative 16 times my t squared plus my v sub naught times t, increased by my, was it 1/2? Yes. The value, that particular t value. Do you guys mind if I stop? It equals some number. Definitely a positive number, so it's making sense to me. What do you think? You guys give me some feedback, because I know a lot of you have not seen any physics. Is this pretty fairly basic?
Mhm.
I hope it's.
It's pretty straightforward.
We learned this in lecture today.
Did you
Well,
really?
Well, to be honest,
That's why you're yawning.
You learn this in like 30, like none of this stuff is new that you're giving us.
You know, back in Math 30, I'll be honest with you, we lied to you by drawing these pictures, because that height function really wasn't this picture. The height function was merely the vertical component, period.
Yeah, but
And I didn't address the range at which my bat's
So-
gonna fly
well,
across.
we didn't have a third thing to define it with. We didn't have a t, so you had to assume that. We just did it x and y. So
Did
now
you
that we
really?
have
Oh.
now that we have a t, we can.
So-
But it's all pretty much the same idea, is what I'm saying. I mean,
So-
there's nothing new per se.
So that was a really silly question, but,
Yes.
okay, so when you found the negative 16 there,
Yes.
I got negative 4.9 like you did, but how did you convert that? I mean, that's
I
it's
didn't.
really,
To be honest with you, I didn't convert it, I just happen to know what those numbers are, at least approximately what the numbers are. The
okay.
reason why I chose the 32, even though I made a mistake, is because when I was just naturally creating an example with Archimedes, I just naturally measured this in feet per second. And that's why I got to use the 32 instead of my.
Okay, so you just,
It's just because.
you just use 32 for gravity, that's all.
You guys, I don't like this. I don't like it because, notice I'm giving the initial velocity in terms of a two-component vector. I mean, often it's the case that I just simply want to look at what angle I make to be able to throw a projectile. And I'll prove this to you. But what angle do you think I would point in above the horizontal to get the maximum range for my projectile?
45 degrees.
Neglecting air resistance, it's going to necessarily be 45 degrees, I agree.
The tan inverse of 5/5, which is 1. Right now, it's 1, so tan inverse 1/45.
Oh, jeepers, that's pure coincidence. Yeah, you're right. Pure coincidence, this example. It's got the maximum rate. Archimedes is very mathematically inclined. He knew this, though. Oh, you guys, can I not assign me homework? I was so overly ambitious today. I meant to finish my discussion even higher dimensional space. Can I just put all the homework together for the weekend?
Sure.
What's the quiz gonna be on Friday?
Do you guys think I can write my in-class quiz Friday on just making sure you're prepared for the exam?
Sure.
Yes.
Okay,
So it'll be on the assignment I signed last night.
the one you assigned last, well,
Yes.
you didn't assign anything last night.
Well,
so-
last meeting, no.
Okay.
That's last meeting.
Okay.
In other words, be able to differentiate, integrate, and take